How to calculate the measures of variability? Standard deviation is the average deviation of scores from the mean. We do not have to learn how to calculate by hand. Rather, we can easily retrieve it from the statistical software these days. Variance is square of the standard deviation. Range of scores is the difference between the upper real limit of the largest maximum x value and the lower real limit of the smallest minimum x. It is quick and easy to calculate, but very unstable. Whenever the two categories of statistical tests. There are two general categories of statistical tests: parametric and non-parametric. The use of the various tests in each category depends on meeting the assumptions for those tests. Parametric has three assumptions about the distribution of the data. The population from which the sample is drawn is normally distributed on the variable of interest. 2. The samples draws from a population have the same variances on the variable of interest. 3. The observations are independent. Non-parametric is called distribution-free statistics because the previous assumptions need not be met. Whenever the assumptions are met, parametric statistics are often said to have more power. The assumptions can be tested by using estimates of skewness and kurtosis. To understand skewness and kurtosis, we first need to know the normal distribution. The normal curve, which is characterized by the mean, median, and mode, are at the same point center of distribution. If the data are in the normal curve, 68% of scores will fall within negative and positive 1 standard deviation. 95% of scores will fall within negative and positive 2 standard deviations. 99% of scores will fall within negative and positive 3 standard deviations. Thus, data would meet the 3 assumptions for use of parametric techniques. Skewness refers to the description of the direction of the hump of the curve of distribution of data and the nature of the tails of the curve. It is about the symmetry of the curve. It shows the direction of the hump and tail of the curve, and tells you if more scores at the positive or negative end. Kurtosis refers to description of the vertical characteristic of curve showing the data distribution. For example, whether the curve is more peaked or flat than the normal curve. It is about shape of the curve. It shows if the curve is peaked or flat. Typically, the distribution of scores is either wider than normal, or narrower than normal. Questions statistics can answer. First, is the effect or relationship reliable? That is, will it occur again? If the effect or relationship is reliable, statistically significant. Second, how meaningful is the effect? We will go ahead to cover the terms and concepts of Chapter 7. Probability refers to the odds that a certain event will occur. Statistics are based on probability. We first need to know the meaning of alpha. The researcher may establish an acceptable level of chance occurrence alpha before the study. This level of chance occurrence can vary from low to high but can never be eliminated. Sometimes called level of significance. Then what does P? It means that if you conducted the same experiment 100 times, 95 out of 100 times you would get the same answer with regard to statistical significance. In the behavior research, alpha is usually set at 0.05 or 0.01. There is nothing magical about 0.05 or 0.01. They are used to control for a type I error, hypothesis or HO. The researchers assumes no difference between groups. In research, researchers usually predict differences. Therefore, we usually want to reject the null hypothesis. If we fail to reject, it means that there were no group differences. Next we will talk about the truth table. In a study, the researcher may make 2 types of error. With type I error, researchers reject the null hypothesis when the null hypothesis is true. That is, a researcher concludes there is no difference between the two interventions, but there really is a difference. We first determine the alpha level, and it is always reported. The current trend is to report actual probability level. Traditionally, we set alpha, and then determine if the results were significant or not. It is typically ignored in the literature. Then, do type 2 errors matter? The level of alpha reflects the type of error you are willing to make. In other words, is it more important that you avoid concluding that one training method is better than another when it really is not? Or is it more important that you avoid the conclusion that one method is not any better than the other when it really is too? Fullness. If results are significant, then are they important? Small differences can be statistically significant reliable, but in the context may be meaningless. For example, if you do a survey study with 2,000 participants, you may find significant correlations among some variables. However, this finding may not be meaning simply because the sample is very large and thus yields significant relationships. Size is the standardized value indicating the difference between the means divided by the standard deviation. It refers to the relative difference between the study variables. Typically, 0.2 is small effect size, 0.5 is moderate effect size, and 0.8 refers to large effect size. It is the power is probability of rejecting the null hypothesis when the null hypothesis is false. It is the probability of detecting differences when they fact exist. In fact, power equals 1, beta, which is type 2 error. To increase power, we can improve the power through the following approaches. 1. Decrease alpha level. 2. Increase number of subjects. 3. Strengthen treatment. 4. Decrease variability in subjects.